Thank you. I'm very happy to be here and see so many people I think have technologies or a need for technologies that is the world that we're in, and we always get excited about it. So if I go ranting and raving, just pick up the occasional pencil and throw it my way. Also, it's nice to see Dr. Goss here, because we've been working with the University of Alberta and Dr. Goss's group now since we virtually started the company. We've been funded as well by National Research Council, and of course we're using SRED dollars to develop our materials and products as well. So just give you a little quick insight of what I do. That's why I have a little demo table here. The biggest issue with soil erosion is not necessarily the erosion itself, but where it ends up. I'm a stormwater guy. I came from the world of stormwater, water transfer systems, pressurized systems, and everything else to move water around. Now everybody realizes gravity does the first part. And I don't know if you can see how, you can see that or not. No, not really. But all the major sediment falls out to the bottom just due to gravity. The problem is that the regulations, as Dr. Goss knows, are changing dramatically across Canada. And what goes from erosion is all that sediment is carrying other materials. The sediment itself is a sponge, and it picks up other materials and transfers that down into the water columns, and then can cause a lot of issues. And as we know, if you're in agriculture, you've got a lot of chemicals and things that can be transmitted. I was doing a project over in the Middle East a couple of years ago, and what they did was they had huge canals going through, and they put in basically shotcrete. So all of the surface runoff coming off the farmer's field, once they did all of their fertilization, so to speak, came down and ran right into the water column, which was a source water for towns. A little bit of our product called water links, and we put it in the water. When we started our technology, what we realized was that there's a lot of products that take sediments and things out of water. The problem is that everybody treats 100% of the mass of the water. So you have a lot of overdosing issues, you have a lot of other issues that come about. And what we said was there had to be a better way to do this. So we started looking at what we call accelerated sediment removal technology. In other words, if we can get the sediment to separate out of the water extremely quickly, then does that make a difference in what we're trying to do? And that's where we started looking at our technologies. And not only that, but coming back in with the processes to remove the sediments as we go forward. So anyway, we're going to go through this here. And hopefully I haven't grabbed the wrong one out of the lab, which is quite possible. No, it's starting to take now. So it's dropping the sediments out. This is very heavily sediment laden. And within a few minutes, what we look at is typically less than 4 minutes we can drop the sediments out. And that's where we looked at the erosion. If we can stop the soil from moving, can we keep the water cleaner? So you see it's really starting to drop out now, and we can get that going at a much better rate. Anyways, my clicker to change this over is, I'll leave that through for a second. Pardon my,
right here.
Here we go.
It's the right button.
Right. So I'm going to go through some things very quickly, but really what we're looking at is population density is increasing no matter where we go. This is worldwide. Edmonton is going to be about 1.8 million people by 2043. And what does that mean to us? Well, what that means to us is that we've got issues of surface runoff going from vegetated surfaces in through the stormwater and increasing from 25% shallow and 25% deep infiltration to now reducing to less than 15% combined once we start putting hard surfaces on. That has a serious, serious impact because our surface runoff is now from 10% to 55%. So we're now managing major chemicals, toxins, hydrocarbons, salts, you name it, in that water course that we talked about. One of the things that Dr. Goss and our group were talking about is what is contributing pollution to stormwater ponds, natural water bodies or receiving waters, air deposits, storm, like we said, inflow creeks, vegetated and non-vegetated surfaces, depending on organic loading and things like that, and then groundwater and discharges. And how much of this could we impact by putting our products together? This is a part of a class I actually do for Dr. Nath at the University of Alberta every year for fourth-year students. And as we can see, that might not be the best way to stop soil erosion. But if you like a 57 Chevy, I think there's one right about there. One of the things that we do hasn't changed. Our technology for soil sediment control has not changed in the last 75 years. When I was in this industry rather heavily in the early 70s and mid-70s, we were doing silt barriers, we were putting in, you know, cuts onto vegetative properties and then putting in cut lines to move the water, et cetera, et cetera. What you notice, though, is the fellow that did this was moving the wrong way along the roadway with his tracks on his cat. So he's created rills by just his cat pads. Now that increases erosion by 54%. We put these wonderful things in and you'll see them everywhere over Alberta. This is probably the biggest saleable item in Alberta and probably Western Canada. And honestly, not one of them was ever installed right, pretty much. This was actually, we walked onto a job site just randomly. I was doing a tour with my staff to show them impacts of this type of technology. It's a great technology, but it stops a migration of soil or sediments from one area to another. It is not an erosion control technique. Erosion control means you've stopped erosion, not stopped migration of major masses of soil. Why do we put a second SRB or a sediment retention barrier in? Well, because the first one failed. This rill was over 4 feet deep. What happened here? They've done beautiful work. This is actually one of the nicest projects I saw in Edmonton. It was very, very well done. The contractor did a good job, according to common technology. But where did we have some issues? Well, they never keyed in the top part of this matting, straw matting. The straw matting that was put in here was virtually non-permeable. Very, very little porosity allowed. So what you're doing when you're trying to grow vegetation, you're agricultural people, so please don't, I'm not. But you know, the simple part is you need sunlight, you need warmth, you need access to the soil, and you need moisture. Well, if you block any one of those off, you reduce your growing patterns. So with this, because there's no ability for the sunlight to get to the seed, it reduces your growth pattern. If you have the reduction, this is designed to block off impact of rain. So it reduces your shear factor or your sheet flow velocity and causes the ability to reduce erosion. But you want vegetation to take place quickly too, because you want to use it as a natural filter. You want to also have the ability to not need all of this material as well. So you've got natural vegetation taking over. They did it here, and then they put an SRB or sediment retention barrier in, and then never stabilized this soil by the creek. This creek actually feeds into a natural stream with lots of fish in it. They put in riprap. Now riprap is an energy diffuser. That's what it does. It diffuses the energy enough so it reduces it by the time it gets down. It's not necessarily an erosion control technique. So what happens is all the mud flows from underneath, scours underneath the riprap, and there was over a foot of mud in this, as you can see here. And that went to a fish-bearing stream. Things like subsurface slippage, not understanding what your soil structure is. You know, not setting up for it. If you know you've got high clay, you're going to have probably water pockets, you're going to have rain events. Start doing some things to mitigate that by putting in French drains across the top or whatever. Again, all of this soil here wasn't stabilized, so what ended up happening was the soil actually went into the stream. So what did they do? Instead of trying to stabilize the soil, they put in drain rock into the stream to reduce the fine sediment flow. As you can see, it's all falling away and fell into the stream. They put in some things like French drains running down the hill, but never ran them across the crown to allow for the water to move. Overall, beautiful looking picture, but look at every one of these riprap areas was actually a failure point where the whole slope gave away. This one was in Ontario. We were called in an emergency to a project, and what they did was put in huge drains to allow for 100-year rain events. Then they put all their straw matting down, but they never stabilized the soil, so all the soil went off into site, flew in, filled up all of their They had a serpentine berm in here to give it water retention time in the pond, filled up the berm, went over to a lift station and right into a stream and caused a $250,000 fine. As you can see, the water is extremely turbid, and so they put another evap pond in, evaporation pond, to try and catch some of that water before it fell in, and then all of that blew out as well and ended up in the pond for another $100,000 fine. We use what we call soil capping techniques. That's the current technology. We'll put on a mulch, which it basically has a guar gum or some other type of a binder in it, and it goes so thick that there's no permeability, so now you've increased your sheet flow, and as soon as it does catch a little pocket of soil, it throws it down the river and starts taking big pockets with it, because now it's glued together, so it starts taking big chunks. And then now, these rails become extremely big. Or, this is Anthony Hendy when they built it actually, and again, they put nice mulch over top of it, but that's, again, to be a soil capping technique. We haven't stabilized the soil yet. What we've done is put some mulch over top of it and allowed for the rain and the vegetation to take place. Problem is, if you look at this, a rain event happens, and then all the sediment flows from underneath it, goes right into the storm drain, and ends up in the receiving point. Straw bales, been using them for I don't know how long, but I remember putting these in the 70s, and they haven't changed since. And honestly, as soon as they go any flow with mud, they fill up, and then they become useless. Again, this contractor didn't stabilize any of the soil, so what's ended up happening is all this erosion goes over, and actually this pushed over a bunch of sediment retention barriers, went right into a natural wildlife sector that's full of ducks and other animals, so it became quite an issue for the local area. Here's that guar gum material that we were talking about, the tackifier, with no porosity, so it didn't reduce the sheet flow by allowing water to go and infiltrate into the soil. So it started taking huge chunks of mud, and that was the end result, and that was a $200,000 fine. We do tons of this in Alberta, just stripping large surface areas, and we don't do anything about the soil area, and that ends up getting into our ponds and causing issues for all the benthic organisms, etc. EPA guidelines in the US now is finding $32,500 per day for violation per incident. One of the clients we've been working with for the last 3 years was facing $2.5 million of fines. He had 28 incidents. For the last 3 years, he has not had one negative comment from the Department of Ecology or Department of Environment, and they've been working with our products ever since. Edmonton, the first fine was last year, February 16th, $200,000. We are now getting into the make it regulated game. Thank goodness. This one here was a major one. They were facing 10 fines at $500,000 apiece. And I don't know what the final settlement was. I believe it was done just in November. Environmental effects of sediment. This is actually from a study we did with Dr. Goss. And as you increase the sediment loading, you increase mortality issues with the fish. It's just that simple. So sediment alone is as toxic as chemicals. It can blind off the food, it can blind off the eggs that are trying to hatch, it can get into the gill tissue, cause oxidative stress, etc., etc. So a lot of issues. Now when we start putting our products on, as we had talked about, we've now taken our sediment load out of the water, so now we can, and the more I keep causing this reaction, the more we can remove the sediment loading, and just keeps getting bigger and bigger and falling out faster and faster. So now I've got this really nice clean water that I can deal with, but I haven't stopped the soil. So we have another product. So we decant our surface water. I'll just pour this right out of there. And then we got a little granular version. And now I can stir this up. We don't need to use vacuum trucks anymore. I just did a big project for Gibson Energy on Sunday, and we demucked a whole pond, oh gosh, I don't know how many hundreds of cubic meters of soil that they didn't have to add an additive like an absorbent. Typically you'll add a straw or a mulch or some other type of absorbent into that material. So we just add our product into it, mix it up, and turn it into a solid, no more slurry. They can take it away in a regular dump truck, reduce their hauling costs by tons. So That's what it's doing here. It's just turning into a solid, and no more slurry. Done. There you go, nice and solid. So it really extremely cost-effective for the operators and large ponds. Because we can force sediment to drop out, we can actually reduce pond size by up to 94%. Now think of that from a developing site of a large mine, large industry, or other type of things. And if we can stabilize all the soil around it as they're doing construction for erosion control, we don't have to worry about mitigating the issue at the end point as much anymore and become more source control. We can save up to 1,600 kilograms per hectare of soil. This was a project over in the Middle East I was on, and basically what we did was watered the whole area, put our products on one side of it, and as you can see, it retains moisture, 25% more moisture, and it retains the furrow stability. Here's with our products applied, no product applied. Now we're working with a major seed company in Canada and the US right now, and we're just in the final trials. They want to actually mix all of our Soil Links products with their turf seed because it actually accelerates growth. This project here was for a major pipeline project. This is the first of many we've done for this company. And they seeded this product, this soil every year. It's highly alkaline soil, major rills. This is taken from a kilometer away, so these rills are the size of a truck. This actually is a mining truck carrying the water. That's how big this hill is. And we came in, put our stabilization on it, put our Soil Links in the seed, and they got that for growth. They had no more erosion issues. This is up in Fort McMurray on hydrocarbon-laden soil. We did 40,000 square meters, and within 8 weeks had full growth. This one actually made it into a magazine. This is actually at Commonwealth Stadium, 29 days full growth. You can use it because it's totally benign. There's no issues for any toxicity issues with the fish or anything like that, so it can go into the streams, the creeks, lakes, doesn't matter. So mix it with your seed and you can do aerial seeding. This was actually a forest fire area. Other techniques to save erosion. Straw bales are bad. Straw loose is good. And we add our granular product right into this straw, and it now becomes a filter. As it goes through and it captures it all, the straw will not plug. It'll actually cause the water to move further down the chain. And then when this is all plugged up, you just put in new straw and recharge it. This has made it into a national magazine. This has never been done before. We did this for a major developer in Edmonton. But we came in at 25 below zero. Normal return on vegetation in dormant seeding is about 40 to 45%. We are actually getting 85 to 95% return. So this was done. We came in with a grader, stripped all the snow off. It was done in 25 below zero. Put all of our product down in June. We had full growth. So the contractor now could develop all around this and had no worries about getting erosion and sediment moving into their watercourse, which is right beside Big Lake in Edmonton. I've got a dust control video. We won't go through it. It's a little bit long, but this is 40 acres stripped. We have a new product out called Dust Links, and this will actually stabilize for dust control. So our major products for dust control now would be all the tech coal mines just came on board, TransAlta Utilities, High Prairie Mines, a bunch of municipalities, and it's all totally environmentally friendly. We have a new product out called Woe Dust, which actually is designed for horse corrals because it's no worries about consumption. And for this particular mine, they were watering 48 times a day on the haul roads. They now water 4. So we've reduced their water usage by 91%, and we've increased the tensile strength of the soil by almost 14%. So it reduces their maintenance on their soil, their structure. This is what we were doing yesterday, basically taking a whole pond and demucking it, turning it into a solid, and then they reuse the soil. And we have other products that we can do for dewatering, etc. Metals values, nutrient reductions. We also get nutrient reductions, so we do wastewater treatment. And that's just a list of products. So that's my speech.
There's nothing like a demonstration of the chemistry at work. Congratulations. I mean, what a contribution. We let that go on a bit because of the visuals, but we do have time for one question.
Questions? Yes, sir.
Can your dust control products be used on, say, gravel parking lots and country roads?
Yes and no. Okay. The reason being is yes, they can be used. The clay content is kind of a contributing factor. If it's big gravel, don't care what you use, magnesium chloride, cal chloride, or whatever, it'll break it up because the rocks actually act as marbles and break it up. So if there's a good clay content in its clay pack, yes, we can. But understand it's a dust abatement, so there is watering required. So what we get is a lot of country roads, they want to put it on there, but then they don't want to water it for the rest of the year. Well, I don't care if you use our product or magnesium chloride or calchloride, you need water. But so there is a watering schedule that's needed, but yes, it can be used for that. Anybody else?